Okay, we're going to talk about the point, line, and plane notes. This is the first set of notes that we took in geometry this year. We start off with the three undefined terms of geometry. These are things that everybody understands what they are, we know how to draw them, but they don't really have a formal definition, something that we can all agree to abide by. These are the kind of building block pieces of geometry. Points, put a bunch of points together and you form a line. And we know that on a line there should be infinitely many points. Likewise, we can put together a bunch of lines and create a plane, much like the plane of a floor or the plane of a wall. And then we can put those planes together to create three-dimensional objects. But nonetheless, here we have three undefined terms, point, line, and plane. What we're going to be focusing on here is how do you name these objects? How do you refer to them in a mathematically correct way? So we're going to start with the point. I expect that you already know how to draw a point, just a dot. And I expect that you probably already know that points are named with capital letters. So here we're going to name our point A. Now when it comes to naming the object, you're either going to write out the word point followed by the letter that corresponds to the point. That's one way to do it. More typically, you're just going to see the capital letter written. So if we see something like A is on line L, then I would know that that point is being referred to. Okay, then we have a line, and there again I expect we all know what a line is. Got arrows on either end, so we have some line here. And as is true in algebra and other math classes, we should have 2 points on that line. So here we're going to have 1, 2 points, and we're going to call these points B and C. So we'll label one with a capital B and one with a capital C. Now when it comes to naming a line, you can write out the word line and then follow that with the 2 letters, and it doesn't matter which order you have the letters in. So this could be written as BC or CB. That's not typical though. The more typical way of seeing a line denoted or talked about is to name the 2 points that the line passes through, and then to draw a little line complete with arrows above it. Here again, it doesn't matter which order we use, so I could use BC or CB, but nonetheless, I want to make sure that I put that little line symbol above the letters themselves. So looking at that name, I should be able to say right away, this person's looking at a line and it passes through points B and C. And then the last one we have is that of a plane. Now a plane we know is a flat surface. We can think of the top of our desk as a plane, or the floor or the wall as a plane, or if your paper is laying on something, you can think of your paper as a plane. But that never-ending flat surface. Now whenever we draw a plane, we typically draw it with a parallelogram, something like so. And it doesn't matter which direction your parallelogram slants. It can slant to the left, it can slant to the right, that won't matter. As long as you've got kind of that parallelogram shape. Okay, so within our plane, we can name this a couple of ways. You can name a plane according to 3 points inside the plane. Now those 3 points have to be non-collinear, and we'll talk about what that means in a little bit. But for now, let's start with 3 points, and we're going to call those 3 points D, E, and F. When we look at planes in our book, there is no special little symbol for plane. Unlike the line where we could draw the line above the letters, here we just write out the word plane. And we identify our 3 points, D, E, and F. You're not putting any commas or spaces in between them, you're just naming one after another. The order of the letters doesn't matter here. In reality, there are 6 different orders that we could use for D, E, and F, D, E, F, D, F, E, and so forth. Now the other way that we can name a plane is that sometimes in one of the corners of the plane, and it doesn't necessarily matter which corner, but you'll see kind of a cursive-y letter written up here. That indicates the name of the plane. You'll know that's what it is because there won't be a dot anywhere around it to indicate that it's a point. When that happens, I can name the plane then according to that letter. So here I can name it plane R. It is not necessary to copy the font that they've tried to use. So you're going to see this little scripted, pretty, frilly kind of font. You can just write an R. You don't have to write it with all the loops and pretty lettering. So we have a point, line, and a plane. Now we're going to look at some things that are formed using points, lines, and planes, definitions related to them. And the first one we have is that of collinear points. Now, if you know what the prefix co means, it means to share or to have in common. So something about sharing here. As we look at linear, that should tell us something else. It should tell us we're dealing with lines. So here we're going to have points on the same line. Collinear points. And that's simply what our definition is. Points that lie on the same line. Now in terms of a diagram, that means we're going to start with a diagram. And we have to have at least 2 points, but you can have more. Here we'll put on 3. And we're going to call these, let's call them G, H, and I. There is no symbol for collinear, so when it comes to describing them, you just simply say G, H, and I are collinear. It just simply becomes a statement. There's no way to shortcut that. Don't try to abbreviate the word in some awkward way. Just write it. All right, now given that, let's talk about coplanar. Remember, co means to share or have in common. Planar indicating that we're on a plane. So here we have points on the same plane. Very similar definition, just changing our line into a plane. So when it comes to our drawing then of that, or our diagram, we're going to start the same way we did a plane before with a parallelogram. And we're going to put some points on here. Let's do 4 points on this one. Name one of them J, K, L, and M. So my statement in this case, J, K, L, and M are coplanar. And then that leaves me with one extra definition on the bottom of this page, and that is that of a line segment. Now this is a definition that's rather long. You're going to need to write pretty small. I expect you already know what a segment is, so you're never going to have to tell me what a segment is defined as being. That's not something I'm going to ask you to do. I may ask you to draw them, I will ask you to name them, but I'm never going to ask you to state me this definition. Ultimately, what the definition, though, does is give us some information about what a segment is. So let's start by drawing a segment. In the definition, it says that it's part of a line, not a whole line, part of a line consisting of 2 points called endpoints. So that means these 2 points that I've drawn are endpoints. And we're going to call our endpoints in this case N and O. And that the segment consists not only of those 2 endpoints, but all the points on the line between them. And that's where we get the segment that we're so used to. Now when you name a segment, you can write the word segment out, but you're not going to see it that way. So if you wanted to, you could write segment NO or segment ON. But the more typical way that we are going to see it is we're going to do the 2-letter approach like we did with a line. But now instead of drawing a line, we're going to draw a little symbol across the top that looks like a segment. You don't put the dots on the end. It's just a bar. You could also write this as segment ON. And anytime I see that, I'm going to read it as segment NO or segment ON. The little symbol above the letters tells me what type of figure it is that I should be seeing in the diagram. Okay, so that takes care of our first few definitions. Let's look at our last few. Array. Here again, I think array is something that you already know about. It's not something that should be entirely new. Definition is long again, somewhat like what a segment was. But as it starts out, it's part of a line consisting of a point and all points on the line extending in one direction. So in this case, I'm going to draw my ray going this direction. It doesn't matter which way that ray points. It could point right, left. It could go point up. It could point down. It could point in any angled direction. It doesn't matter. In any case, whichever direction it points, regardless of which direction it points. This point here, the one we started with, is called the initial point. Just like your initial is the beginning of your name, the initial point is the beginning of that ray. And then we have to have some other point on this ray. It is part of a line after all, so it's got to have 2 points. And that second point, the one that it passes through, is what's called the terminal point. Now, if you really think about it, terminal usually means to stop or to end. A ray does not stop at that point. It keeps going through that point. Now, why is that important? Well, we're going to call that initial point P, and we're going to call our terminal point Q. And when it comes to naming them, it is very particular as to how you have to write the name of a ray. You start by naming your initial point, and then you name your terminal point, and draw the ray. Now, the ray is always drawn pointed to the right. We start with the initial point, then list the terminal point, draw an arrow above it pointing to the right. Always. Just because you reverse it, don't reverse it. We're always going to have it go to the right. There may be other textbooks that don't do it that way. You may find resources online that have it pointing the opposite direction and reverse the letters. I do not want you to use that notation in this class. Now this next one we're going to look at is putting rays together. So opposite rays are rays that share an initial point and extend in opposite directions. So they share an initial point. So we start with some point, let's call that R. And I need 2 rays that point in opposite directions. So either one's going to point left, one's going to point right. Or one would point up, one would point down. Or one would point to the northeast and one would point to the southwest. But in either form, they need to point in opposite directions. Now, because those are 2 rays, and remember each ray, like what we have above, needs 2 points on it. So here on my ray that's pointing to the left, I'm going to put a point S over here on the left. And on my ray that started at R and pointed to the right, I'm going to add another point T. So I have 2 rays now. Initial point on one is R, terminal point S. Draw my ray. And the other ray, R as the initial point, T as the terminal point, with my ray symbol, are opposite rays. You'll notice that those form a line, and typically whenever we're talking about a diagram of this type, we'll simply call it a line. But we need to understand what the idea is of opposite rays, and that will kind of come into a couple of other things later in the year as we talk about things formed by rays. All right, intersect. To have one or more points in common. Now at this point, you should have had some experience in algebra with intersecting lines. For example, we know that when 2 lines intersect, we create a point. In this case, we need to start thinking about, well, what about other objects that intersect? Maybe the intersection of 2 planes, for example. So if I think about a plane, and I'm not terribly decent at drawing these, but let's kind of sketch ourselves a rectangle. Remember, a rectangle is a parallelogram, so that is actually a plane. Now I'm going to draw a kind of eyeball where the middle is here. I'm going to draw another thing. I'm going to draw a parallelogram this time. We kind of have to see where those cross. Now we have to see that. That's not terribly good at all, is it? Let's see. Take that part back. Maybe it won't. Maybe it will. There we go. Okay, let's try this again. I want that to be as parallel as I can get it to the top of that parallelogram. Now I should see in this case 2 points where what appeared to be my parallelogram and rectangle cross, and I'm going to draw a line through those 2 points. Like so. So how does that look like 2 planes crossing? Well, sometimes shading it helps a bit. So I'm going to use a lighter color here, and I'm going to shade this plane in this color. like so. And notice what that does is I color this one in. It like blocks from view this part of this plane back here behind this pinkish color. I'm going to take another light color. Let's see, let's use a blue this time. And I'm going to color on the other side of the line, but I'm not going to color in the same polygon. I'm going to color in now my rectangle. And there again, as I do that, you can see that that hides from view part of that pink plane that extends behind it. So now as I start to color in my other areas here, and back there in the back on the other side, you can see how those two planes intersect, but you kind of have a blocked view of what's going on behind the blue, for example, or behind that purple pink color. So as I think about a line that maybe is on this pink plane, I know it's going to not only come through here, but it's going to kind of be hidden right here and then extend back here onto this plane. But nonetheless, the important part here is as two planes intersect, what is created? Well, in between them where they cross, I can see that they have all of these points in common. And keep in mind, those planes are going on forever. So what's actually being created by those two planes is this line. So the intersection of two lines becomes a point. And the intersection of two planes becomes a line. And we'll start looking at other intersections as well. You can also imagine the intersection of two planes by imagine the way the floor of your room intersects the front wall of the classroom. So the floor of my classroom and the front wall, well, they intersect right along the baseboard. And that's pretend that these walls go on and this floor goes on forever. That baseboard's going to go on forever. So that becomes my line where those two planes intersect. All right, so you can go ahead and mark angle off here. That's one that we are going to include on a separate set of notes that we had originally had on here to begin with. All right, so let's name some objects then using a diagram. Use the diagram for questions 1 through 6. Name a point on line M. So I want to start by identifying what line M is, and I can see that here. There's line M. And on line M, there are 3 points. There's point B up here where these lines all cross, right there. And there's point E where these 2 lines intersect. And there's point F where those 3 lines intersect. So name a point, as in a single point on line M. I could name either B, or I can name E, or I could name F. And any of those would work as being a correct answer. One thing I forgot to mention earlier, you can name a line by a little letter off to the side. So instead of using 2 points with the line symbol above it, you can use this lowercase letter like we see here with the Q, or there with the P, the N. Uppercase letters indicate points. Lowercase letters indicate lines. And you'll usually see that written off to the side of the diagram. Okay, so let's go on to number 2. Name a point on line S. So in this case, we're going to find line S right here, and we want to name a point on that line. Now here we can see that there are 2 points of intersection, C, where those 2 lines intersect, and F, where those lines intersect. So either one of those would consist of a point on line S. Next question. True or false, A, B, and E are collinear. So let's identify where A is, there, B, and E. Now to be collinear, that means I should be able to draw one line that goes through all 3 points. And hopefully we can see here that that's not going to be possible. So does that make A, B, and E collinear? No, it doesn't. So that becomes a false statement. 4, name a point collinear with D and E. So let's identify where D and E are. So there's D and there's E. If I want collinear, I want it on the same line, and I can see that D and E are on this line. So I want another point on that line besides the 2 that are already named. Well, I can see that there are 2 points of intersection on those lines. I've got point A, and if I follow that line down here, I can also see point G. So a point collinear on the same line with D and E would either be point A or point G. Okay, 2 more to go. Name 3 points that are not collinear. Now there are multiple answers here. The only thing you want to worry about is 2 of them may be collinear, but the third one can't. So for example, let's say I picked A and B. Those 2 are on the same line. They're both on line P. Whenever I name a third point, I need to make sure that I have a third point that is not on that same line as A and B. So I might pick E, I might pick D, I might pick C, and so forth. So I could name A, B, and D. Or I can name A, B, and E. Likewise, if I had just chosen any 2 points to begin with and I picked E and G, then to not be collinear, that means I cannot pick points or other points on line R. So here I could not pick point D and I could not pick point A, but I could choose F. Ultimately, when things are not collinear, when 3 points are not collinear, we're going to end up with a triangle being formed. When they are collinear, we get a line. So there's all kinds of answers available here. And then we've got one more. Name the intersection of lines Q and R. So let's find lines Q and R. Whoops, wrong tool. And R. And we want to see where they intersect. And hopefully we can all see that they intersect at point G. All right. And that's it for the end of the notes.